Okay, so again, there's the data analysis and on the freestyle again. So the next thing is maybe a little bit more complicated, but it's also start from what you have here. So you open up all your 9 files and then our test, like, so for this video, we're going like, if we want to find a particular peptide that is elute as a particular point, and then like we're going to integrate the MS1 as our to help us quant. So what we're going to do, like the reason to do that is like for like these are TTR proteins. Okay. And then you can see like we have the iodine on H51, H76, and Y134. But sometimes like, and we were going to have like for TTR, like we want to compare for different condition that is like for like 9 different runs. And sometimes we don't have the same site pass through the filters that for the C have. So we want to go back to our raw data, mass spec data to see if like to know if whether it is like because like mass spec select precursor to fragment randomly if you're not doing target method, and when we run a standard method, like we are not running target method, so for it will be harder. Like for TTR, it's like less abundant protein in serum, so like it will be really easy for mass spec to see serum albumin and like select serum albumin peptide for precursor, like as precursor to fragments to get MS2. And MS2 is what you can get for your peptide ID. So if you don't have MS2, you don't have peptide ID, then you cannot have you don't have intensity for the signal, and then you will not be able to get a good fit. So what we want to do, but we know like the label peptide should be there already, whether it is like get MS select for MS2 or not. So what we want to do is look for MS1 data and to see if we can quantify it differently if we already have something ID. So just saying like this H51, if that is what we want to see, what we want to look for. So you come like after you have your export peptide data, I'm just going to start from here. So here you want to see an iodine label. So you can sort it by PTM type, and iodine 125. Let's start from there. So you can see like everything's up here has iodine. So let me just select like one of them. I think this should be start from 69 to 90. So I think this is like the 76. So 69, 70, 71, 72, 73, 75, 4, 75, 76. So yes, this peptide is one of this peptide. Okay. Oh, sorry. H676. Here we go. So it is SM over Z. Oh, shoot, this is a quant data. So to get the M over Z, so we need the M over Z information. So you need to export your, and what am I looking at? Okay, this is the same size. So you want to go to a spider to get your M over Z. And let's wait. It will take a while. So usually for CHAP, you only need label reads. So if we want to look for those M over C, like MS1 data, you need to go back to your project and export your spider. And because it is running like another analysis right now, so it will take a long time to open it up. So let's wait patiently. So yep, so I need an M over Z to show you the next step. So let's just do it a bit. Or so when we are waiting for an M over Z value, let's come here. So what you can do, like it is showing TIC right now. And what we are going to do next step, we're going to do an EIC, like ion extract, like a specific mass range extractions. So we're going to change it to mass range, and this is the time consuming process here. Okay. It also takes a while. Let's see if we got the spider yet. No, not yet. And then you're going to enter a range, like saying if we're going to see like 1, 2, 3, 4.5, 6, 7, 8, M over Z, and with a like mass tolerance like 0.5 ppm, and you hit enter, and it's going to change the first files for you to just look for that range with that ppm. It will take a while, and let's see if we got our spider. Okay, we got it. So let's go to protein tag and find our TTR protein. I know the accession number is because I do it a lot. So this is our TTR protein. So you go to peptide again, and then just say I'm going to look for this one. I'm not in time. So it has an iodine tag here, and you can confirm it is because like the mesh tag is here. Oh wait, shoot, what did I do? Let's do this one. Okay, wait a little bit. Okay, I'm going to pause a little bit. Okay, so let's do this one. It has an iodine tag, like 125, like monoiodine modification on histidine. And then we're looking for M over Z X61.0217 at retention time 95.53. So let me remember this one, X61.0217. Come back here to change that X61.0217. X61.0217. Let me see if it is correct, but okay. Huh. Interesting. So now it is waiting. So we want to see something that is at 95 minutes. So great. The major peak is right here, which is a huge peak. So, and then you're going to change all of it to that kind of. I'm just going to do 2 as examples. But when you're doing it, you are going to do all 9 for one, and then we will get a quant for it and see if we can get better, and we will use those numbers to fit into CHEV and see if we can get better fit for those like particular peptide, like particular site that we are looking for. And it will be a time-consuming process, kind of. So that's why JCs will say, like, if we can use Skyline, that is the next things we can try. Okay, and then just these 2. And then, so it's good that like they're all there. I'm just going to do 3 just to take a look. So to look at our retention time besides TIC, what we can also do is also do an EIC extraction to look at if the retention time aligns. And oh gosh, so that is for these things, like it takes a while because for each step it takes a long time to think. So make sure you have something else to do while you're waiting. Just is a good time to multitask a bit. I kind of regret I did it, but you're going to change. I'm going to, you know what? I'm not going to change that. I'm going to change the ppm here to 0.05. It will give you more narrows, like a peak that is more accurate than what we're looking at. And you can see a difference between when it is 0.5 and 0.05. Wait, interesting. Actually, I got more stuff. Okay, that's interesting. But I did not expect that to happen. But let's go with 0.5 right now. That is something we need to play with. But no matter what you're doing, just make sure you pick a ppm that consistent like between all your like analysis. So as long as like the parameters consist, we're good. Okay, let's wait for it to get there. Okay, now I'm really confused, but it's okay. So this is like that peptide we're looking for, and now I'm going to zoom in to just there, and then you can see a really pretty illusion across the range. I am a little bit confused here because this one it looks for exactly that mass. And this one is looking a little bit across. Okay, well, let's do just to serve a principle. I'm going to hide all the other spectrum that just takes like make our time easier. So you can see like it has a really pretty Gaussian curve. And what we're going to do right now, we're going to just integrate the peaks. And then you're going to pick detections here, select genus, and just keep the parameter as it is. And better just take a screenshot because I'm still trying to figure out what exactly the peaks like this parameter mean, but it is just one thing we can do now just to starting trying different things to get better result for our TDR data. And then you hit apply to all plot, like it will be the plot that you displayed, I assume. And then you hit applied, and it's now thinking, and it will pull like generate a peaks integration like area for you after it finished thinking. And then it takes a while. So here we go. So it has two peaks. So here for trace one, we're looking at because I zoom in from like 95. So it start integrate from 95 and it tells you like the base peak is like 86.02. We want it to be more exact though, so we need to play with that a bit, but it gives you the peak area that is what you really care about. And then you can see like it is the peak like retention time from 90 like 5 minutes all the way to 95.99. That is what we really want to look at. So what you will do is then you will copy all of it. I think you really just Control C and copy and go to the one of your Excel sheet and then just paste it. So it gives you like the file you have that is 0, and what you really want to care is the peaks area here. For that is, that is for 0. And then you're going to just like, we will going to just sum that for our, that to be our signal intensity for our 0. So turn to scientific. So we know it is 0 here because it is saying here that is trace 1. Okay, and then you go to your trace 2, that is your second file. And like it starts from 96. Okay, so it doesn't have a lot. Oh, it starts from 95 to 96. So do the same things. And then just copy them. Like actually we'll copy the entire table whether you like or not. And then come here and copy, paste that. And that is for your trace 2. And then again, sum them up, and then you're going to create another table like across that cell, like from 0, like 0.75, 1.5, 2.25, for that is for E light. And then you will put this number here, and you can have a better smart way to do that. I'm just going to paste as number for now. And then here as your second value. And then when you get all the 9, you fit it into C and see if it likes it. Yeah. So that is like how you're going to extract chromatography from, like do the quantification using MS1 instead of identification. So you can see it's like really lengthy process, because we're going to find like a couple of peptide, a couple of the sites we're interested in. You're going to going through this kind of manually. So we will need to find a better way, but it's a good start. So hope that helps. Okay, I'm going to stop this. Okay, stop recording.